Traffic flow and analysis. In mathematics and transportation engineering, traffic flow is the study of interactions between travelers, including pedestrians, cyclists, drivers, and their vehicles, and infrastructure including highways, signage, and traffic control devices, with the aim of understanding and developing an optimal transport network with efficient movement of traffic and minimal traffic congestion problems. There are three main variables to visualize a traffic stream: the speed, the density, and the flow. The speed simply tells how many length of space have been traveled per unit of time. Density tells the number of vehicles per unit of space or length. And the flow, also known as the volume of the traffic, tells the number of vehicles per unit of time. Now let us discuss them one by one. Speed. Speed is the distance covered per unit time, and one cannot track the speed of every vehicle, right? So in practice, average speed is measured by sampling vehicles in a given area over a period of time. There are two definitions of average speed: the time mean speed, or also known as mu sub t, and the space mean speed, also known as mu sub s. Now, for mu sub t, it is the average of speed. It is also the arithmetic mean of speed. So to solve for mu sub t, you simply divide the summation of the speed of each vehicles all over the number of vehicles. And for mu sub s, also known as the average speed or the harmonic mean of speed, or the space mean speed, don't forget that main definition of the two. Madami kasi siyang tawag, guys. So, para aware kayo kung ano-ano yung mga terms na ginagamit for them, nilagay ko na lahat. Okay? So, to solve for the space mean speed, you simply divide the number of vehicles by the summation of the reciprocal of speed. So guys, don't worry, no? Kasi sa PowerPoint na pinrovide ko sa inyo, nababasa yung equation, pero dito hindi ko alam bakit nawala yung equation. Anyway, let's move forward. So the next important parameter here is the density. Density is defined as the number of vehicles per unit length of the roadway. In traffic flow, the two most important densities are the critical density and jam density. The maximum density or the maximum achievable under free flow is Kc, while Kj is the maximum density achieved under congestion. In general, jam density is 7 times the critical density. And the inverse of density is spacing, which is the center-to-center distance between two vehicles. So don't worry about spacing. We're going to talk about that in a while. Last is the flow. It is the number of vehicles passing a reference point per unit of time. Vehicles per hour is the unit of flow. The inverse of flow is the headway, which is the time that elapses between the ith vehicle passing a reference point in space and the 1 plus ith vehicle. In congestion, h remains constant. As a traffic jam forms, h approaches infinity. Now, let's talk about the formulas that we will use later on sa ating mga problem solving. So, we have this basic formula here, which is mu s is equal to q over k. Kindly refer na lang sa PowerPoint para makita nyo talaga yung formula. What is K? That is the traffic density. It tells how many number of vehicles are there per length or per space. Then we have the Q, or the flow or volume of traffic. And then we have mu sub s, or the space mean speed, the average speed, or the harmonic mean of speed. Next formula is for the spacing. Spacing is equal to 1000 over K. So, K is the traffic density in vehicles per kilometer. Then S is the spacing in meters. And of course, wala ito. Okay? Naligaw lang yan, guys. Okay? So, that's the second formula that you need to memorize. And the last formula is the peak hour factor. So, what is the peak hour factor? Peak hour factor is simply Q over Q max. Q is the flow or volume of traffic, and Q max is the maximum flow or volume of traffic. Now, let's proceed to the problem-solving part. So, using the formula that I introduced a while ago, we will solve the 5 sets or 5 items here. So, number 1, the spacing of vehicles in a road is 80 meters center to center. If the average speed of the car is 50 kph, determine the volume of the traffic. So, nahanap natin yung volume. So, we are looking for Q. Right? We are looking for Q. Now, ano ba yung formula na pwede nating magamit if we are looking for Q? Of course, we can use this first formula. Okay? Pero wala pa tayong value ng K, but we already have the value of the average speed. Take note that average speed is your mu s. So, this is unknown. Ito yung hinahanap, si Q. This is given. Okay. So, to solve for K, we can use the spacing formula. We know that spacing is equal to 1000 over K. And since we have the spacing of 80 meters, take note ha, yung formula na 1000 over K is given the situation na si S ay naka-meters and then naka-vehicles per kilometer si K. So, meters naman yung 80. And then we proceed directly to the formula and we can solve for K in vehicles per kilometer. So, that is 12.5 vehicle per kilometer. And we can now solve for the value of Q. So, from this formula, we know, or to solve for Q, we simply multiply mu s and K. So, mu s, again, we need to convert 50 kph. Or hindi na, no? Hindi na pala kasi naka-kilometers per hour siya, tapos naka-vehicles per kilometer. So, makukuha natin Q is naka-vehicle per hour. Okay, so diretso na tayo, guys. So, we have 50 times 12.5. So, what is the value of Q? So, 50 times 12.5. Therefore, we have 625 vehicle per hour. So, that's our answer for number 1. Next, number 2. The spacing of vehicles in a road is 30 meters center to center. If the average speed of the car is 60 kph, determine the volume of the traffic. So guys, pareho. Iniba lang yung given. So diretso na tayo, guys. So first, we solve for, we are asked to find the volume or the flow of the traffic. So again, we will use the formula, mu s times k. Saan galing yan? From the formula that mu s is equal to q over k. Okay, and then, let's solve for k. So, for k, we have the spacing is equal to 1,000 over k. So, what is k? K is 33.33 vehicle per kilometer. And then, we substitute it directly. Since we already have mu s, no? Mu s is 60 kph. K is 33.33. So, what is Q? Q is 1999.998 vehicle per hour. Okay, next problem. The volume of the traffic is 625 vehicles per hour, and the average speed of the car is 50 kph. Find the approximate center-to-center spacing. Okay, so ang hinahanap natin is yung spacing. And we know that to find the spacing, of course, we need the value of the density. Okay, so we have 1,000 over the density. Now, let's solve for the density. So, to solve for the density, given naman yung mu s and given naman yung q. So, mu s is equal to q over, so this is q, this is mu s over k. So, what is k? $12.5 vehicle per kilometer. Okay? Next problem. Problem number 4. Guys, parang naulit lang to. Na? Nakopy ko lang yata. So, let's move to the next problem. So, the hourly volume of traffic is 2,000 vehicles per hour. So, this is Q. While the highest 5-minute volume is 300. Within 5 minutes, so this is your Q max. Highest kasi, no? Find the peak hour factor. Okay, so isolve muna natin yung Q max. So, we are looking for the peak hour factor. And we know that the formula is Q over Q max. And then, guys, we solve first for Q max. We know that Q tells us how many number of vehicles, so there are 300 vehicles, over unit of time. So the time here is 5 minutes. Kumbaga, within the 5-minute time, 300 vehicles you know observe within the given area. So we have 5 minutes. But we know na it should be in vehicle per hour. So we simply convert minute to hour. So we know that in 1 hour, we have 60 minutes. So this will cancel out. So what will be the result? So we have 300 all over 5. So what's the answer? 3,600 vehicle per hour. And we will use that to find the peak hour factor. So peak hour factor is equal to Q over Q max. Okay. So we have 0.5556. Okay. Next problem. So this is the last problem, and this is a situational problem. So we are given the data. It is a freeway surveillance. There are 5 vehicles traveling distances S when observed on 2 photographs taken every 2 seconds apart. So the time elapsed is 2 seconds per each vehicle. So determine the space mean speed, determine the flow of traffic, then determine the density of traffic. So to solve for the first item, determine the space mean speed or mu sub s. Again, what is the space mean speed? It is equal to the number of vehicles all over the summation of the reciprocal of the speed of each vehicle. So we know that speed is simply distance over time. And stated naman sa problem, no, na ang time elapsed per each vehicle is 2 seconds. So, ayan, idiretso na natin, guys. So, we have the space mean speed is equal to number of vehicles. So, we have 5 vehicles all in all. And then, reciprocal, summation of the reciprocal of the speed. So, reciprocal of speed is time over distance. So, i-add lang natin yung time, 2 seconds for each vehicle, over yung distance na na-travel nun. So, for the first vehicle, the distance travel is 24.4 plus time over distance ng second vehicle plus time over distance ng third vehicle plus time over distance ng fourth vehicle plus time over distance ng fifth vehicle. And then that is your space mean speed. That is 5 over 2, 24.4 plus 2 over 18.8 plus 2 over 24.7 plus 2 over 26.9 plus 2 over 22.6. So we got 11.5696 meters per second. Or, to convert it into kilometers per hour, okay, we simply multiply it by 18 over 5. Multiply it by 18 over 5, that is 18 over 5 kph per meter per second. So, this will cancel out. So, guys, yun yung ginagamit kong conversion, ha. Kapag gusto ko i-diretsyong i-convert from meter per second to kph, i-multiply ko lang siya ng 18/5. So, times 18/5. So, we got 41.6506 kph. Okay, so that's the answer for the first item. Next item, of course, determine the flow of traffic. Okay, so guys, to solve for the flow of traffic, we know that the flow of traffic tells us how many vehicles are there per unit of time. So guys, ilan bang vehicles yun nandito? There are 5 vehicles, right? And ano yung time ulit? Diba 2 seconds per each? So, 2 seconds. And then, i-convert mo lang ito guys into hour. So, ilan ba yon? In 1 hour, we have 3,600 seconds. So, that is your flow. That is 9,000 vehicle per hour. Okay. Then the last item. So, determine the density of traffic. Using the formula, μs is equal to Q over K. We can solve for K by dividing Q by μs. So, what is the value of Q? We have 9,000, right? And what is the value of μs? Let's go back. μs is 41.6506. So, what is K? K is 216.0833 vehicle per kilometer. So, that's it guys. That ends our discussion under the traffic analysis. So, see you on our next lecture. Bye!